Hello friends, today my video is on imperfection or defects in solids. Actually, what do you mean by imperfection or defect? Defect means there is some irregularities in the arrangement of the particles. Or imperfection, both are similar words, synonyms. Its meaning is that if we do the arrangement of the particles, if there is any departure or dislocation of particles in the arrangement, then that is called imperfection. It means, first I am writing the definition. It means any dislocation or any type of dislocations or deviation of particles from the proper arrangement, arrangement of particles in crystal, then it is called imperfection. This is called imperfection, or it is also called defect. It means if we are arranging the particles in proper ways, if there is any type of dislocations or deviation of the particles from the proper place, or it may go outside of the crystals, then that will cause imperfections. As we see that at 0 Kelvin temperature, the crystals are ideal. Crystals actually ideal. Crystals are ideal. When temperature is increased, suppose above 0 Kelvin, then what happens? The particles actually dislocates, because we see here at 0 Kelvin the entropy would be delta X is equal to 0. It means there is no randomness or disorder of the molecules. But above 0 Kelvin, what happens? That delta S greater than 0, delta S will increase, entropy will increase. So there may be the possibilities of dislocation or deviation of the particles from the proper arrangement. Then that particle is defect, because it causes dislocation of the particles. Particles will move, the randomness would be greater, so the particles will shift from one position to another position. This causes defect or imperfections. So just we see here, but what will happen if there becomes the defect or imperfections? If there becomes the defect or imperfections in the crystal, then their properties due to imperfection, what happens? Their properties are being changed. Properties properties are changed. What properties will change? We see here, we can say here density, it will change. We see here conductivity will change. Magnetic properties will change. Stability also changes. It will also affect on stability. So there are so many properties will change due to imperfections. Their properties will change. Their properties may be changed regarding the densities, conductivity, magnetic properties, stability. There are so many properties will be changed. Now see here, we have to know the types of imperfections. There are actually two types of imperfections. See here, there are imperfections are of two types actually. One is the electronic imperfection and other is, first is electronic imperfection. And other is, that is point imperfection or defect. You may write defect. Perfections, electronic defect and point defect. Electronic defect, it means it is related to disarrangement of the electrons. It means what happens, it is due to disarrangement of electrons. Disarrangement of electrons from its position. From its position. Suppose, as for example, if I take silicon, germanium, we are taking here. These are covalent in nature. One silicon example, suppose silicon or germanium it is. What happens as the temperature is increased above 0 Kelvin? What will happen? The electrons will be in higher energy state. Electron will have higher energy. Will have higher energy. So that electrons will just shift to the other side. So that causes movement of electrons. This causes movement of electrons. And if the electrons will move, their conductivity will increase. It means it will affect the properties. It affects on the properties of the crystal. Suppose now I am going to take here the example of this silicon and germanium. See here, just I am going to draw the figure. Suppose this silicon, this is its valence electron is 4. So one silicon is bonded with 4 other silicons covalently. Like this. See here, just at greater than 0 Kelvin temperature. 0 Kelvin. If the temperature is increased above 0 Kelvin, then what will happen? The electrons are here. These electrons are bonded. These electrons are bonded. See here, these electrons will get higher energy. Their energy state will be higher, just above 0 Kelvin. Then the electrons, these suppose, these electrons, any of the electrons, some of the electrons will, that is removed from its sides. Electron is removed. It causes holes. This will form holes. So many holes can be formed. Due to holes, this, now the crystal changes its properties. Due to holes, it causes conductivity. Conductivity. It becomes a conductor. Now when electric field is applied, what will happen? The electron will shift to the holes and creates a hole here. Electron will shift to the other. Again, other electrons will shift to the holes. So electrons will move forward. Electrons move forward, whereas the holes that moves opposite to flow of electron. These electrons, mobile electrons, and the hole are represented by, see here, this mobile electron, it is represented by E, and the hole, it is represented by H. And their concentrations can be represented, concentration of these places. On the basis of concentration, electrons, that is negatively, so on the basis of concentration, it is represented by N, and the hole, that is deficiency of negative, then that would be P. N type and P type semiconductor will be formed due to the electrons and the holes created in the crystals. So this is called electronic imperfection, electronic defect. What would be its consequence? Its consequence will cause that it becomes conductor, because it creates a hole, and the movement of holes and the electrons are opposite to each other. That movement of electrons causes conductivity. Now, other type, that is point defect. Point defect means there is a minor defect. It means any particles. Here what happens? Departure or dislocation of particles, not electrons, particles from its lattice sites, lattice site. So that is called point defect. It means if there is any departure, then it will cause, if there is departure, then it will cause vacancy defect, and if it dislocates, it means it dislocates, it means it remains in the crystal but its position is being changed. It shifts from lattice side to the interstitial side. So that is called interstitial defect. So this point defect are commonly of two types. One is vacancy defect and other is interstitial defect. Now in my second video I shall give you about the point defect in ionic crystals, and I think in second part you will watch the remaining part of the defect easily. And today I just request from all of you to like this video and also subscribe, and you may also send me the comment of this video, but you will watch the next part soon. Thank you.